China's mega machines just broke the rules of physics, and US engineers are shocked. You're about to see 14 machines that do things textbooks say are impossible. These aren't concepts or prototypes. They're operating right now, moving weights that should collapse under their own mass, reaching heights that should crumble, and building at speeds that defy every known construction principle. And the first one moves like a creature that shouldn't exist. The Iron Monster, SLJ 900/32. You're looking at a machine that walks on bridges it's building. The Iron Monster stretches 300 feet long and weighs over 1,000 tons. But here's the impossible part. It picks up entire bridge segments weighing 750 tons, carries them forward, positions them with millimeter precision, and then walks itself onto the section it just placed. Think about that. This machine stands on the bridge piece it installed 60 seconds ago, supporting its full weight on concrete that just locked into place. It has 64 wheels distributed across its length, and it moves by extending support legs, shifting its weight, and essentially caterpillaring forward. Bridge construction that used to take crews 3 months per section now happens in 2 hours. The machine does this completely autonomously, calculating weight distribution and structural integrity in real time as it advances. Engineers said you couldn't build a machine heavy enough to lift bridge segments that could also support itself on those same segments. The Iron Monster does both simultaneously. But that's just moving weight on land. Jianghai Tunnel Boring Machine. The Jianghai is a tunnel boring machine with a cutting head that measures 62 feet in diameter. That's wide enough to swallow a 6-story apartment building whole. But the size is just the beginning of what makes this machine impossible. It's designed to bore through the most unstable geological nightmare on Earth: mixed rock and water-saturated soil simultaneously. Traditional boring machines pick one or the other. The Jianghai cuts through both at once while working 300 feet below sea level. The cutting head spins with 300 individual disc cutters, each one applying 30 tons of pressure. That's 9,000 tons of total cutting force concentrated on the rock face. But here's the part that violates physics. As it cuts, it instantly stabilizes the tunnel walls with pressurized bentonite slurry while installing concrete segments, all in one continuous motion. The machine prevents water intrusion, cave-ins, and structural failure happening in the same second. It carved the Taihu Tunnel beneath one of China's largest lakes, boring through conditions that shift from granite to liquid mud within feet. And it never stopped. Not once. But if you think cutting rock is impressive, wait until you see what's dredging the seafloor. MV Tian Kunhao. The Tian Kunhao doesn't just move earth. It creates land where there was only ocean. This dredging vessel is 460 feet of pure island-building power, and it's rewriting geography itself. The machine carries a cutter head that pulverizes underwater rock at 30 revolutions per minute, generating 6,000 kilowatts of cutting force through tungsten carbide teeth that shred basalt like tissue paper. But here's the impossible part. It sucks up 36 million cubic feet of seafloor material per day and precisely deposits it to build islands from nothing. The ship can dredge 115 feet below the surface while pumping that pulverized rock and sediment through massive pipes over 9 miles away. Think about that scale. It's vacuuming up mountains from the ocean floor and spitting them out as new landmasses miles away with positional accuracy measured in feet. The Tian Kunhao built entire island chains in the South China Sea, some spanning over 600 acres, in months. These aren't sandbanks. They're stable land formations with bedrock foundations that now support runways and buildings. The machine turned open ocean into solid ground. But creating islands is one thing. Lifting what you build on them is another nightmare entirely. Taizun. Taizun can lift 20,000 tons straight up into the air. You heard that right. 20,000 tons. That's the weight of 200 fully loaded Boeing 747s. And this crane hoists it like you'd lift a coffee cup. The crane sits at Yantai Raffles Shipyard with 2 massive towers rising 430 feet into the sky, connected by a lifting beam that spans 400 feet across. But the engineering impossibility isn't just the weight, it's the control. Typhoon lifts entire ship sections, offshore oil platform modules, and bridge spans with hydraulic precision, moving loads that would buckle steel under their own mass. The crane uses a system of pulleys and cables where each cable is thicker than a human torso, and it distributes the load across points calculated to the pound. When it lifted a 20,000-ton offshore platform module in 2008, engineers worldwide stopped and recalculated what they thought was possible. The crane doesn't sway, doesn't wobble, doesn't hesitate. It just lifts weights that shouldn't be liftable, with movements so smooth you could balance a glass of water on the load. Then came the question, what if you needed that power to be mobile? XGC 88000. The XGC 88000 is a crawler crane that moves 4,000 tons while driving on tracks. This machine weighs 2,000 tons. By itself, stands over 500 feet tall when fully extended. And here's the part that makes no mechanical sense. It doesn't need outriggers for stability. Traditional cranes this size require massive stabilizing legs drilled into bedrock. The XGC 88000 just rolls up to a job site on 96 crawler tracks and starts lifting. The boom extends to over 700 feet, and at that length, it's hoisting wind turbine nacelles that weigh 600 tons to heights where the air is thin enough to affect hydraulic performance. But the crane compensates in real time, adjusting hydraulic pressure and counterweight distribution as wind loads shift. The counterweight system alone is an engineering miracle. Over 2,000 tons of modular weights that reconfigure automatically based on load, angle, and extension. When it installed wind turbines in Inner Mongolia, it lifted components to heights of 450 feet in wind conditions that grounded every other crane on site. The machine just kept working, recalculating physics with every gust. But at least that crane stays on land. Zhenhua 30. Zhenhua 30 floats on water and lifts 12,000 tons like gravity is optional. This isn't a stationary crane. It's a self-propelled floating fortress that travels across oceans under its own power, positions itself with thruster precision, and then hoists weights that would sink conventional vessels just from the rigging alone. The crane vessel stretches 764 feet long, with twin lifting booms that reach 382 feet into the sky. But here's what violates naval engineering. It maintains absolute stability while lifting these impossible loads in open ocean swells. Waves that would capsize cargo ships just roll beneath Zhenhua 30 while it's hoisting bridge segments weighing thousands of tons. The vessel uses a dynamic positioning system with 8 thrusters that fire continuously, making micro-adjustments every second to counter wave motion, wind loads, and the shifting center of gravity as the crane rotates. It installed the Hong Kong-Zhuhai-Macau bridge sections in conditions where the margin of error was less than 4 inches over spans measuring hundreds of feet. And it did this while floating, moving, compensating for tide changes, and operating in a place where physics says you can't have a stable lifting platform. But that's still lifting objects that already exist. Honghai Crane. The Honghai Crane moves containers so fast, it looks like time-lapse footage playing at normal speed. This is an automated port crane that can lift and position a 70-ton container in under 90 seconds from ship to truck with 0 human operators. The crane stands 400 feet tall, with a boom that extends 230 feet. And here's the terrifying part. It's making calculations faster than human reaction time, while moving loads that would kill dozens if something went wrong. The trolley system accelerates to speeds that would throw containers off traditional cranes, but Honghai uses predictive algorithms that account for wind resistance, container weight distribution, and momentum transfer in real time. It doesn't just move fast. It moves with precision, measured in millimeters, while operating at speeds that generate forces conventional cranes can't handle. The system processes sensor data from 64 points on the crane structure simultaneously, adjusting cable tension, trolley speed, and hoisting velocity thousands of times per minute. At Shanghai's Yangshan port, these cranes handle 40 containers per hour each. That's one every 90 seconds, running 24 hours straight, with accuracy that puts human operators to shame. Then came mobile cranes that made even this look slow. XCMG XCA 4000. The XCMG XCA 4000 is a mobile crane that lifts 4,400 tons and then drives away on public roads. Think about the contradiction in that sentence. This machine hoists weights equivalent to 44 fully loaded semi-trucks, and then it disassembles itself, drives to the next job site, and does it again. The crane has 12 axles, 216 wheels, and a telescopic boom that extends to 600 feet while supporting loads that should snap steel like breadsticks. But here's what makes engineers question reality. The counterweight system uses 2,000 tons of modular weights that reconfigure based on lift angle, and the crane calculates the exact configuration needed for each job automatically. Traditional cranes this powerful are permanent installations that take weeks to assemble. The XCA 4000 sets up in hours. It lifted a 2,000-ton petrochemical reactor to a height of 300 feet with wind gusts hitting 40 miles per hour, and the load never deviated more than 6 inches from center. The hydraulic systems operate at pressures that would explode conventional cylinders, using reinforced steel that's manufactured to tolerances measured in thousandths of an inch. But lifting things is still straightforward physics compared to what comes next. Intelligent Micro Bump Jacking Formwork System. The Intelligent Micro Bump Jacking Formwork System builds skyscrapers by climbing up the structure as it pours it, and the entire process is autonomous. This isn't a crane or a prefab system. It's a self-climbing robotic formwork that shapes concrete floors while rising vertically through the building like a mechanical parasite. The system uses hydraulic jacks anchored to the building's core that lift the entire formwork platform upward in increments of 13 feet once each floor cures. But here's what makes no engineering sense. It pours, finishes, and sets concrete for multiple floors simultaneously while climbing. The machine maintains laser-level precision across floor plates spanning hundreds of feet, adjusting for concrete settlement and structural deflection in real time. It built the Ping An Finance Center in Shenzhen, a building that's 1,965 feet tall, by advancing upward continuously without ever stopping. Traditional formwork requires cranes to reposition everything between floors. This system just jacks itself up, resets, and pours again. It completed 4 floors per week, with concrete finishes so precise they needed 0 additional leveling. The machine essentially grows the building from within, but pouring concrete is still conventional material. What comes next isn't. 3D printing. China is printing entire houses in 24 hours, and the structural integrity exceeds traditionally poured concrete by 30%. These aren't small demonstration models. We're talking about full-scale 2-story residential buildings with load-bearing walls built by robotic arms that extrude concrete layer by layer with positional accuracy measured in millimeters. The printing nozzle moves at speeds up to 6 feet per second while depositing concrete mixed with fiber reinforcement that cures as it prints. But here's the impossible part. The printer creates hollow core walls with internal geometric patterns that increase strength while reducing material weight by 40%. Traditional concrete walls are solid and heavy. These printed walls use less material and hold more load. The printer built a 600-square-foot house in Suzhou with curved walls, integrated plumbing channels, and electrical conduits, all printed in one continuous process. No formwork, no waste. No separate steps for different building systems. The machine just prints the structure, complete with channels for utilities already embedded in the walls. And it does this with 0 construction waste, using only the exact amount of material needed. Then came vertical reach that makes even skyscrapers look small. Zoomlion 101 meters truck. The Zoomlion 101-meter concrete pump truck throws concrete 331 feet straight up into the air, and the material arrives at the top with the same consistency it had at ground level. That's a 30-story vertical throw of liquid concrete that weighs over 240 pounds per cubic foot. And it's happening through a boom arm that shouldn't be able to support its own weight at that extension. The truck has a 7-section carbon fiber boom that unfolds like a massive robotic arm, reaching heights where air pressure affects concrete flow. But here's the part that breaks fluid dynamics. It pumps concrete at a rate of 210 cubic yards per hour through pipes that are fighting gravity with every foot of elevation. Traditional pumps lose pressure, and concrete separates at half this height. The Zoomlion maintains consistent flow with sensors that adjust pump pressure in real time based on boom angle, concrete viscosity, and atmospheric conditions. It poured the upper floors of Shanghai Tower, pumping concrete over 1,000 feet above ground level through a boom that flexes and sways but never loses its calibrated arc. The concrete arrives perfectly mixed, ready to pour. But pumping concrete still requires human workers to finish it. Bright Dream Robotics. Bright Dream autonomous construction robots are building skyscrapers with 0 human workers on site, and they're coordinating like a hive mind that never sleeps. These aren't remote-controlled machines. They're fully autonomous units that navigate construction sites, identify tasks, and execute them with precision that makes human crews look clumsy. Each robot uses LiDAR mapping to build real-time 3-dimensional site models, tracking every beam, column, and obstacle, while calculating optimal movement paths that avoid collisions with other robots working simultaneously. But here's what makes this terrifying. The robots learn. They analyze completed tasks, identify inefficiencies, and modify their approach without programming updates. A fleet of these machines built a 20-story residential tower in Shenzhen, handling everything from welding steel frames to installing exterior panels. The robots worked 24 hours straight, never took breaks, never made measurement errors, and completed the frame in 60% of the time human crews would need. They communicate through a central AI that assigns tasks based on priority and robot position, reorganizing workflow dynamically as the building rises. When one robot detected a misaligned beam, the entire fleet adjusted their subsequent work to compensate before a human would have noticed the problem. Then came machines that took railway construction to another level. CPG 500 Track Laying Machine. The CPG 500 track laying machine installs railway tracks at speeds that turn months of work into days. And it does this with millimeter precision across distances, where human error would derail trains. This machine is a self-propelled track factory on rails that carries 500 meters of pre-assembled track, weighs over 800 tons, and lays down complete railway sections, including rails, sleepers, and ballast, in one continuous operation. But here's the impossible part. It positions each rail with tolerance of just 2 millimeters, over spans of 1,000 feet, while moving forward at speeds up to 2 miles per hour. The machine uses laser-guided alignment systems that survey the terrain ahead, calculate optimal track geometry for curves and grades, and adjust placement in real time as it advances. Traditional track laying requires crews to position each sleeper individually, align rails by hand, and verify measurements repeatedly. The CPG 500 just rolls forward, extruding finished track behind it like a mechanical spider spinning steel web. It laid over 600 miles of high-speed rail corridor in 18 months, working through mountain passes where track curves required precision that would take human crews weeks per mile. The machine never stops, never miscalculates, and leaves behind track rated for trains traveling at 220 miles per hour. But even railway precision is primitive compared to what's moving entire structures across oceans. Yihang Jinyun 2. The Yihang Jinyun 2 is a semi-submersible heavy-lift vessel that sinks itself underwater to load cargo, then resurfaces carrying weights that would snap conventional ships in half. This isn't a cargo ship. It's a floating platform that submerges its entire deck 40 feet below the surface, allows massive structures to float over it, then pumps out ballast tanks to lift everything back up as a single unit. The vessel stretches 772 feet long and can carry 68,000 tons of cargo. But here's the terrifying part. It does this while maintaining structural integrity across a hull that's essentially a giant bathtub, supporting weights distributed unevenly across its deck. The ballast system uses 32 separate tanks that pump seawater in coordinated sequences, submerging the vessel at precisely calculated angles to prevent tipping, while 20,000 tons of water per minute flows through the system. When it lifted an entire oil rig platform, the structure weighed 46,000 tons and sat asymmetrically on the deck. The Yihang Jinyun 2 adjusted ballast distribution across all tanks in real time, surfacing with a rig perfectly balanced despite center of gravity that would capsize normal vessels. It transported offshore platforms, damaged ships, and floating dry docks across oceans, carrying loads that can't be craned because they're too heavy to lift and too large to fit in harbors. The vessel just swallows them whole. But moving cargo across oceans is nothing compared to machines that never stop moving on land. The XCMG XDE 440 is an autonomous mining dump truck that hauls 440 tons of rock without a single human touching the controls. And it operates in conditions that would kill a driver in minutes. This machine weighs over 400 tons empty, stands 3 stories tall, and navigates open-pit mines using LiDAR and GPS, with positional accuracy measured in inches while traveling at 37 miles per hour on roads that don't exist on any map. But here's what makes this terrifying. It doesn't follow pre-programmed routes. The truck analyzes terrain in real time, identifies optimal paths based on grade, surface conditions, and traffic from other autonomous vehicles, then executes turns and speed adjustments that would require years of human driving experience. The haul bed tilts hydraulically to dump loads from heights of 20 feet, and the truck calculates the exact tilt angle needed based on material type and weight distribution to prevent tipping. It operates in Inner Mongolia coal mines where temperatures swing 70 degrees between day and night. Dust clouds reduce visibility to 0, and the truck just keeps running, 24 hours straight. No breaks, no shifts, no driver fatigue. The fleet coordinates through central AI that optimizes traffic flow, preventing bottlenecks at loading zones while maximizing tons moved per hour. Human-driven trucks achieve 60% efficiency. These autonomous machines hit 94%. But hauling material above ground is nothing compared to what's drilling miles beneath it. The XCMG XZ16000 drills tunnels under rivers, mountains, and cities without disturbing a single grain of dirt on the surface, and it steers through solid rock like a surgeon's scalpel through tissue. This horizontal directional drilling rig can bore holes over 3 miles long, with diameters wide enough to fit pipelines 4 feet across, all while curving around obstacles you can't see and navigating by instruments alone. But here's the impossible part. It drills at angles up to 45 degrees from vertical, changes direction mid-bore when it hits unexpected geology, and maintains positional accuracy within 6 inches over distances of 16,000 feet. The drill head cuts through granite, shale, and clay while sending real-time data back to operators about rock density, temperature, and drill bit wear. Traditional pipeline installation requires digging trenches that destroy everything above ground. The XZ16000 just punches through underground, emerging exactly where calculations predicted miles away. It installed gas pipelines under the Yangtze River, drilling through bedrock 200 feet below the riverbed, while cargo ships passed overhead, completely unaware. The rig applies 1,600 tons of thrust to the drill string, rotating the cutting head at speeds that generate enough friction to melt rock, while pumping drilling mud that cools the bit and carries pulverized stone back to the surface. It creates infrastructure tunnels in places where surface construction is impossible.